Okay, so we're doing a lesson still on Chapter 2 on transformations, but today's lesson's on Section 2.3, which is composite functions. I've written two of the equations just at the top here, because this is what we're going to be focusing on for today, which is at the top you can see we're looking at the product. So if we have fg of x, then that can expand out to be f of x times g of x. And I purposely wanted to do these two together because if you take a look at this one that I'm pointing at the bottom here, or underlining right here in pink, you can see that it looks almost like the one that's above it. Notice that there's that hollow circle in the middle. That notation is what tells us that this is a composite function, meaning the g of x, and I've done it in a different color so you can clearly see where it's coming from, that actually goes into the outer function f of x. So what that's saying is whatever the whole blue g of x function is, that's going to be substituted into our bigger function f of x. And I think to get more clarity on this, I'll show you with some actual examples. But just laid out clearly at the top there, you can start to get a sense of the subtle differences between those two. I've chosen to go through these together because I know from past experience that these are both situations where people often get confused. So I feel if I show it to you together, hopefully that'll bring some clarity and we can avoid confusion with this. So it says here, another method of combining functions using substitution. So this actually is based on things that you've done before. You've done lots of substitution, but this time instead of substituting in numbers, we're actually going to be substituting functions. So we can start off with something that's nice and familiar, and then we can work our way up to some more complicated examples. Okay, so if we scroll up and take a look at our first example here, it says if f of x is x squared and g of x is 3x plus 2, then find f of g of 2. Now, again, just to make it a bit easier, hopefully, to work with, I am going to assign colors to these. So I'm going to underline this one in a blue, and I'm going to underline this one in a pink, so that we can keep track of what we've got going on here. So basically, we're going to figure out what g of 2 is first, and then we're going to substitute that into the larger function, which is f of x. So I'm going to number this and say step number 1. Let's work with the pink stuff. Let's figure out what g of 2 is. Now this, if we were just to do g of 2, that is review of something you've been doing for the last few years. So I think the way to make this all easier to work with is if we do it step by step. And so if you look at it as these separate little steps that we eventually put together, I think it makes it a lot more manageable than to look at the whole thing and to get overwhelmed by it. So if we have g of 2, that means into our function g of x, we're going to plug in a 2 wherever we see x. And so working our way through this, we get 6 plus 2. So from doing this, we find our g of 2 is actually equal to the number 8. And now putting this into our bigger function, because I guess what I could say, I'm going to draw it this way, is I could say that this is like f of 8, because we already determined in pink here that g of 2 is equal to 8. So we're using our the idea of substitution in order to make sense of this. If g of 2 equals 8, then f of g of 2 must be f of 8. And so we're simply taking that and plugging that in. It was equal to x squared, but we just said instead of x we're using 8. So it ends up being f of 8 equals 8 squared. And what I like to do is, at the end, obviously we know 8 squared is 64, but I think it's nice to sort of put things together at the end and to show where this came from. So to make this super clear, what we're saying is f of g of 2, when we put it all together, ends up being equal to 64 overall. Maybe it would have been helpful if I called this step number 2, so I'll do that now. But so that's a nice way to break it down into smaller steps and then put the whole thing together at the end. And it doesn't feel quite as overwhelming if you take that approach and break it down into little steps. Okay, so if we take a look at the next one, which is part B, I'm going to shrink this down a little bit so we can see everything. This time it doesn't say f of g of 2, it actually says f of g of x. So I'm going to use the same approach. I'm going to underline it with pink because that's what we assigned our g of x as. And then we're going to look at f of x as the bigger, larger outer function. So this is, I'm going to use the same step-by-step approach, but this time we're going to have, or maybe it's better if I say this. This is equal to, or the same thing as saying f of, and if I don't have a number to plug in for g of x, then I have to just take what the equation is that it's equal to, which is 3x plus 2. So what I'm saying is I want f of 3x plus 2. And I'm going to plug that in to whatever f of x was. Actually, I'll carry on down here. I know that this is like saying f of x equals x squared. So what I am saying here, I should get rid of the f perhaps. So I guess that would be like saying equals x squared. I don't know if I'm confusing you by doing that, but what I'm saying is f of g of x, or if I look at the bigger function like f of x, it's equal to this whole thing, x squared. So the 3x plus 2 is being substituted in for the x. So here I would have f of g of x equals 3x plus 2 all squared. And so what we would do in this case is we're just simply multiplying them out. 3x plus 2 times 3x plus 2. And we could use our FOIL to do this. So I'll carry on up here because I'm running out of space. And actually I'll move the whole thing up so you can see it better. So we would get 9x squared when we do that, plus 6x, plus when we move down to here, another 6x, plus, we can do that, 4, and we want to combine our terms. So after we do all of this, we get 9x squared plus 12x plus 4, and that's what we get for our f of g of x when we don't have a number to plug in, but we're actually plugging in the algebra. Okay, so to practice the same type of idea, let's do find f of g of x, for f of x equals x squared and g of x equals x minus 2. This would be a good time for you to pause the video and to try this on your own, because I've just walked through a couple of examples of how to go through it step by step. So that would be my suggestion. Hit pause, try this on your own, and then come back to it to see my solution. I am going to carry on, but you can do that. That's the nice thing about this online thing. You have the freedom to go at your own pace. So again, if we are looking for f of g of x, maybe a helpful way to write this, nope, I want to keep it consistent. So I'm going to say f of, and g of x is equal to x minus 2. So I'm going to substitute in x minus 2 into there. And if that's the case, well, x minus 2, this whole thing would be equal to x squared, but it's not x. My x is being replaced by this x minus 2. So my f of g of x, when I put the whole thing together, would be what was x squared, but I'm plugging or substituting in the x minus 2 into it. So it's x minus 2 squared. And again, you don't have to take the time to actually physically go through this, but I will show you step by step so you're very clear on where this is all coming from. We know that we would get x squared. That's going to be minus 2x and another minus 2x, so we get minus 4x. And at the end here, minus 2 times minus 2, we're going to get plus 4. I just like doing this to show very clearly what we were doing and where it all came from. And we can circle our answer as always to make it nice and clear. Solving equations is definitely about knowing and doing the math, but also about communication. So get into the habit of demonstrating your work clearly and in an organized manner. So it doesn't matter who's marking it, who's looking at it, they should be able to figure out what's happening. So generally, this is the part we just finished. I'm just sort of summarizing. This is what I had written at the start, but this is what we've just finished practicing. So kind of nice to see what that would look like. I'm just going to show you one other quick example that takes this a step further. So if I know that this is a composite function because of the little hollow hole in the middle. Like, that's not a multiplication sign. This is how I know I'm talking about composite functions. So what if instead I have 3 of them, and I have something that looks like this? So just so you can see what this would look like, because the thing is, questions look like they're getting harder. They're not really getting harder. We're just adding on another layer or another step. But if you still use that basic step-by-step approach, you will not find that it's super overwhelming. So really what this is saying is, I'm going to use a big bracket because we have a bunch of things going on, and we basically go from outside to inside. So I would take f of g of h of x. So to make sense of this, so again, starting with the inside, working your way out, I'd figure out what h of x is. Then I would plug that into g of x. And then eventually, whatever that answer was, I would plug into f of x. So start with the inside and work your way out, and that's what's going to make this nice and easy to work with. It takes something that appears complicated and confusing, and it breaks it down into smaller steps so it's no longer confusing for you. Okay, so now let's take a look at if f of x equals x squared minus 1 and g of x equals root x, find f of g of x, the domain of f of g, and sketch the graph. Okay, so let's start by looking at this. If we just have x squared minus 1, that's just a parabola that's been moved down. We know that by looking at it, and you don't have to necessarily sketch this out, but we know it looks roughly like that. And so if we're looking at the domain, we know from past experience the domain of that is just going to be all real numbers because those arrows come out slightly on either end. And then if we take a look at this, remember we talked about restrictions? So for the restrictions we would look for are under the root sign. So we would say x must be greater than or equal to 0 because we talked about this last day. You can't, it's going to be an imaginary number. If you have a negative like root -4, you can't do that. So that's where that restriction comes from. So I think it's nice right at the start to take a look at what two functions you're starting with to start to wrap your head around what the domain of the new function would be. And then the next part is going through it kind of like the stuff we just finished doing. So if this is my bigger function, f of x equals x squared minus 1, this is the one that's being plugged into it. So to set this up, my f of g of x is what I am working with or what I'm looking at. So another way I could write this is like saying f of, well, g of x is equal to root x. So I could say f of root x, and I could rewrite this. Could have said this was x squared minus 1. So when I take this and substitute it in to wherever I see the x squared, what it's ultimately saying, I'm going to do it like this. Keep it all the same, but then look at what I'm substituting in. What I'm substituting in is the root x. If you take a look at it, the square root of x squared, so basically I'm just left with x minus 1. So another way I could write this, f of g of x works out to be x minus 1, which also is something that we are familiar with. If it's x minus 1, we know that that's a linear function. We could graph that out. It's just a basic line. But we also want to talk about the domain. So when we go to talk about the domain, we have to choose the most restrictive part of this. So I go back to my original functions. Although x squared minus 1 was all real numbers, my root x was actually x is greater than or equal to 0. So my domain for this, so domain, is going to be x is greater than or equal to 0 when I go through this. So when I go to sketch out what that looks like, so there's my x-axis, there's my y-axis. In a linear equation, just to recap or review as we're going through, this is telling me the y-intercept, so it's at -1. I'm going to put a little dot there because I know that's where it crosses. Normally I'd have it like do the slope, so the slope of this is 1, so I'd go down 1 over 1. But if this is telling me my domain has to be greater than or equal to 0, so I'm only graphing to the right. I can't go into the negative x values because I'm restricted based on my original functions I started with. So if my slope here is 1, I'd go up 1 over 1. There'd be my next point. I could do that again. And oh no, that's not what I want to do. I want to start there and go that way. And I do want to make sure that circle is colored in because we do include 0 in that. Had this been an open, if this was just x is greater than 0, then I'd put an open circle there. But since it's greater than or equal to, I have colored in the circle at the -1. So that's the graphing component and how to sort of put this all together. Again, if you're having a hard time or you're unsure, pause whenever you need to is my suggestion and try it on your own. And then I would come back to look at the solution to sort of help you or guide you with this. Now, given these two functions, f of x and g of x, let's find g of f of x and state the domain. So again, because we just went through one together, I think it would be helpful if you paused, tried this on your own, and then come back to look at the solution afterwards. If you just sit there and watch me go through all of them, same thing as when you're in class. If you're sitting there and watching me do it, it's easy to passively say, oh yeah, I get that. But to actually try it on your own and to be able to do it without my guidance is when you really get to see if you've understood it or not. So definitely do try that instead of passively just sitting there, which I know is tempting, but it's not going to help you in the long run. So we want to, just like with the last one, take a look at the restrictions here. So we know that in this case with rational equations, you don't want a 0, or we can't have a 0 in the denominator. So I would say here, x is not allowed to be equal to 1. There's my restriction on the first one. Okay, and if I take a look at this one, same thing, like the denominator can't be 0, so I'm going to say x is not allowed to be -1. So there's our starting point. Always start off by looking to see, are there any restrictions? If so, what are they? We clearly label them, and then we move on from there. And then we would do g of f of x, and I need to make this thicker so you can see it well. G of f of x, and oh, why am I slacking? Let me do the f of x as usual in blue, g of f of x, and I'll do the g of x in pink. The only thing is this time they're reversed because you're used to seeing f of g of x, and this is g of f of x, but don't let that throw you off. You're still doing exactly the same thing. So to get a sense of what this is we would do g of, and instead of f of x, I'm going to plug in there what it's actually equal to, which is x over x minus 1. And still carrying on with exactly the same format and step, we would want to actually take that and plug it into what our g of x was. So to make it super clear, hopefully, or that's my attempt, is to make it super clear, I'm going to go like this. I'm going to take my whole pink g of x, set it up exactly the same way. I'm going to write here g of f of x, but I'm putting brackets there to show you that's where I plug in that whole blue thing. That's where my f of x part is going to go. So instead of an x here, it's going to be x over x minus 1, which is what I got here from my f of x, which also needs to be thicker. There we go. So far so good. It looks like it could potentially be kind of bad, but not at all. All we need is, to be able to work with this, we need a common denominator. So again, don't let this throw you off. So it's a complex fraction. There's a bunch of things going on. All you need to do is look for similarities, and if they're not there, create them. So 1 over, well, I'll do this in blue to keep it consistent, but if we have x over x minus 1, we can actually rewrite this plus 1 to make it x minus 1 over x minus 1. We can rewrite that, like, luckily it was just a 1, because that makes it nice and easy for us to work with. So by doing that, we have a common denominator. So now what looked like this horrible, ugly mess is actually not a big deal at all. I'm going to do that because I don't want to keep writing it over and over again, but I think just to get some clarity as to what's going on, it's helpful to not forget like where this came from. This is a lot of stuff to manage. I really think organization and using the colors and like going step by step is all stuff that's going to help you. Again, this is why I want to start with this chapter, because this is laying the groundwork down for everything. If you use this format, this layout, it's going to make everything a lot easier to keep track of. And I really think half of this is just organization. It's not even that math is hard or it's hard to, you just need to keep organized, keep track of things, and you won't find it to be too bad. So we don't really need to write it out again, but I guess we will. At the bottom, we can see we have a common denominator, so it's just going to be x minus 1. But at the top, x plus x would give us 2x minus 1. So we have 1 over, and just to make it super obvious, like I don't really need the brackets there, but I think it just, I'm trying to make it obvious that we have 1 divided by this fraction at the bottom. So a nice way to deal with that is we can flip it and multiply by the reciprocal. So it would be like saying, and again, you don't actually have to do this, but I want to make sure that you all see where this is coming from. I'd flip it and multiply by the denominator, so it's like saying x minus 1 over 2x minus 1. So after all of that hard work, our g of f of x all ends up being x minus 1 over 2x minus 1. We want to talk about the domain as well. So if I look at this, the domain was x. Well, if you take a look at this, we don't want 0 at the bottom, so do you see that x is not allowed to be equal to 1/2? But we also had that it couldn't be equal to plus or minus 1 from our original functions that we had started off with. So this is what we're going to get overall, and after all of that work, this is our solution. And now maybe I've made this too thick, but that's what we're looking at. Okay, let's do the opposite. I don't know if you've noticed this pattern, but we always learn a skill and then we go backwards. And the reason for that is because that's what really shows true understanding, is if you can go forwards, make sense of how to do something, and then work backwards. It's sort of like coming full circle. You get to really grasp and understand the concept if you're able to go both ways with it. So just so you get where it's coming from, that's what's happening. And I don't know if you've picked up on the pattern, but that's what you've been doing all these years. But you're so busy doing it all, you probably don't notice or pick up on these things. So decomposing a composite function is exactly what it sounds like. We were working backwards. So given h of x equals root x plus 5, find two functions f and g that give f of g of x equals h of x. So again, if you need to pause, I would pause. If you need a minute to just sort of, I would try this on your own because yeah, I haven't shown you yet, but this is based on, this is a good application of what we did because you don't really need me to show you and to walk you through it. You can think your way through this based on what we just went through. And also, people, when it's face-to-face, often will ask, doesn't that mean there could be more than one right answer? And the answer is yes, there could be. It just depends on, and I love this section because people's minds work differently, so I view it one or two different ways and other people will hand in something totally different. But I am going to walk you through a few steps that I feel are going to make this easier to manage and to understand. Everything I go through is a suggestion. I encourage different ways of learning and doing things, and I love hearing back from you because I learn as well that way. So if you have another way, of course, you can do this. There's lots of different ways with pretty much everything that we do. Lots of different ways to solve it. So pick whatever makes the most sense to you. It has to be your way of learning and doing this. So if we have h of x equals this, I'm trying to take this. Oh, what? This thing has a mind of its own. It was so thick in the last one. Okay, so if we have this, we want to take that and split it apart or think of, like, work backwards and think of what are two things that could come up with that or create that. So I'm going to rewrite this way. F of g of x, we're saying, is all equal to h of x, which happens to be root x plus 5. So when we look at this, I'm thinking, okay, so what and what? Like, what is something I could substitute into another function in order to come up with this? What I have found over the years that makes this easier to wrap your head around and to make sense of, for me anyways, I like to start with, or I ask myself, what is the bigger function? What is the main function that we're looking at? So when I look at this, what stands out to me is the root sign. So I would make since f of x looks to me like the bigger function, I would look at this and say, okay, my f of x is equal to root x. So it's like I'm treating this stuff as like a separate thing, and I'm just looking at it and thinking, okay, what type of function is this? Is it a radical function? Yes, it is. Is it a rational function? Is it a linear function? Like when you look at it, what is the outer function? And it's radical. That's why I've done this. So then, according to this, my g of x must be the linear function x plus 5. Yeah, there's other ways you could set this up, but I feel like sometimes people make it unnecessarily complicated. So why not? That's actually what math is about. It's taking complicated patterns and breaking them down to find simplicity. So let's keep it simple. This is the easiest way to break this down. Okay, same idea, but it looks slightly different. So if we have h of x equals this, and we're trying to break it down into f of g of x using the same approach as what I just thought of, or what we just went through, I'm asking you, what is the bigger function here? So if you were to strip this down into its most basic form, so this is what we're, actually I should have put this up here. That is the same thing as saying f of g of x, like this. And then I'm just going to take it and break the whole thing down for you over here. So my f of x, I'm going to say, is 1 over cube root x. I like to take this approach, and if you find it easy or useful, you can do the same, and if you don't, you're welcome to show me or choose another way, but then you can just plug in the linear equation into the other part. So, and you don't even need me to mark this stuff. You could take this and basically do the reverse to see if it does end up giving you this end result. So we can see that it does work. So when we break it down, this is what I would get. Okay, moving on. This is our last example. Radius in feet after t minutes, yes, that's a t, is given by r equals root t. So the r being the radius. Express the volume of the balloon as a function of time. In case you've forgotten, because I get that a lot of you probably have, here is the formula to refresh your memory for the volume of a balloon. You should probably know that, but I find most people don't. So if you don't, I'm happy to share that with you on a quiz or a test or whatever we have going on. But we're going to use it, so I'm sure you'll have it memorized or you'll know it. But anyhow, if we know that, then how can we basically rewrite in function notation using composite functions the way we've been doing? Again, I would pause this if I were you, and I would try it on my own, and then come back to it, to me going through it once you've had a chance to do that. Just like in class, I'm even drinking my tea while I teach you. Okay, so basically, let's go back to this. Radius r in feet after t minutes is given by this. So basically, it says express the volume as a function of time. So for starters, I know that I want to rewrite this in function notation. It's saying as a function of time, but I can see here that even time has a relationship with the r. So do you see that, like working backwards, I could rewrite this. Maybe I'm going to do that off to the side. I could say that is r of t equals root t. You can wrap your head around that, work backwards. This is the same thing. This is function notation for this equation. So it's not different, it's the same thing, just a different way of saying it with more details, showing where it's coming from. So in here, I would say the volume is a function of time, but then there's another layer to it. I know that the time also depends on the radius. So I can rewrite this to say the v of r of t equals 4/3 pi, and then when we get to this part, r cubed, well, we looked at how r of r of t is equal to root t. So I could say here root t cubed. So I've substituted in the fact that r is equal to root t because it's in A asking us to put this as a function of time. So it's like I'm using the r as a step along the way, but what we're ultimately doing is connecting all the different parts of this. You've done stuff like this in the past, but you didn't do them in this format, like written in this format. You did separate little steps. This would probably be a question in the past where you'd have like part A, find the radius, part B, find the volume, but you'd have to use all of this. And now it's putting it all together so that you can see how they sort of connect and fit together. Part B, after how many minutes will the volume be 4,000 feet cubed? Feel like, again, I'm probably going to say this about everything all year, but this really feels like review. I hope it does for you. But basically, I think you've maybe done the hard part. If this is saying after how many minutes will the volume be 4,000 feet cubed, we plug that in for volume. So in our equation, we're going to have 4,000 that we're plugging into here equals 4/3 pi times root t cubed. Now you can sort of see the reason why we have this set up the way that we did, because if I had had the original equation with just the r, I'd have to throw in some more steps to try to figure out what the t is based on that. But we've put it all together using our composite functions all into the same equation so that now instead we can just work our way through this, and the rest of this is just our algebra skills. I am going to break it down step by step so that you have this to refer to, especially because it's online and not face-to-face. But I wouldn't expect you to write every single nitpicky little step. I'm doing this to make it super clear for you. I am going to say this: if you know yourself and you know that you make little mistakes like leaving off a negative or multiplying by 3 instead of dividing by 3 or something like that, then you should also get into this habit. This is the best way to minimize or eliminate like the little mistakes that hurt here and there. If you go through, make it super clear and organized and go step by step, you'll find it a lot easier. So algebra is all about opposites. You've probably heard me saying this for many years. This is like saying root t cubed times 4 pi over 3. So the opposite of that would be by multiplying 3 over 4 pi. So I'm doing that all in one shot because I know you can handle that, and you are able to pause the video if you want to slowly wrap your head around what's going on there. So we're multiplying by 4 pi over 3, so the opposite of that on this side would be multiplying by 3 over 4 pi, because if I had done that here, multiplied by 3 over 4 pi, you can look at it this way. The 3 would cancel out there, the 4 pi would cancel out there because it's at the top and the bottom. So what we would end up getting down here on the right side is I would only have root t cubed left on that side. Now maybe a nice way to do this is 4 is going to go into there and leave me with a 1. So just to clean this up, and I do suggest this, go through it step by step, and like you can probably plug a bunch of them into your calculators, but I often see people like, you do the work and figure this out. There are some calculators where you can punch things in exactly as they are and they do the work appropriately. Others, not so much. You have to set it, like input it in a very specific order, and if you don't do it that way, it messes things up. So you figure that out, how your calculator works, and whether you, I think it's better in most cases than not to actually just do it by hand. Like not fully by hand, but as much as you can. and leave the rounding and any of that stuff until the end. We try to get as accurate an answer as possible. The best way to do that is to leave the plugging in and that stuff until the end if you can. So sorry, this was, no, I started talking and then I didn't go through this properly with you. So here we would have 3,000 over pi. Let's do that to start with. We would just have 3,000 over pi. And then what we would want to do is basically work through the algebra on this side. So do you see that we would want to, in order to get rid of this part, the opposite of this would be to cube. This is like square rooting and then cubing. So on here, I would want a cube root to get rid of that part. And then the whole thing would be squared. So that's taking care of this all in one shot. I hope I didn't just confuse you. I don't think so, because I'm breaking it down step by step. But basically, if I have this whole thing cubed, the opposite is cube rooting. That's what I've done in blue here. And if this has a square root symbol, the opposite is squaring the whole thing. So to get just t, I would want to punch in 3,000 divided by pi, cube root it, and then square it. Probably the best way to do it, because obviously cube rooting it, shrinking it down first, will get you to a small number before you square it. But if you're just punching it into your calculator, it's going to do all that for you, and you'd get around 96.97. Notice the squiggly equal sign to indicate that it's approximately equal to. Another way to do it is to put an equal sign with a dot on top. I'm just saying hi to students that are waving at the door in case you're wondering what's happening. See, it's just like you're actually in class. It's the real thing. And the best thing to do when you are doing this is to write it in a sentence. Always, when you have a word problem, I remember this from when I was in school. It's annoying to write it into a sentence, but there's a reason for it. It's easy to just take a formula, punch in numbers, and spit out an answer. But do you actually get what you just found? Do you get what it represents or what it means? And sometimes, even if the sentence is right and you show that understanding of you know what's going on, but the answer you calculated is off by a bit or whatever, you will get some marks to show that understanding, because that's actually what this is all about. So the volume would be 4,000 feet cubed after approximately 97 minutes. And yes, you can abbreviate it and take shortcuts like that. I don't mind. The main thing is that you are able to clearly articulate your answer and show how you're coming up with this stuff. So that was a long lesson, and if you've had me before, you know that I love these things. Since I discovered these, I'm going crazy with them, and you're going to see them all the time. But there's your assignment for the day. This is your suggested assignment. Again, you go with what works for you, meaning if you feel like, oh yeah, I've got this, and after you've done a few of them, you really are into the flow and you get this, you don't have to do all of them. If, on the other hand, you've done them all and you're still a bit iffy, then do more than what I have suggested here. So this O.L means odd letters. So meaning A, C, E, you do the first one and then skip. And the reason for that is just the book gives tons of examples, lots of extra practice. So my suggestion would be to do those that I have listed, just do the half of them or the odd letters. And then when you're studying for the tests or the whatever is coming up, you could go back and do the other ones if you want to. And that's it.